Hello everyone, we are about to start a broadcasting with Peplink webinar. We see many people rushing in, so just please wait a bit. Just hold on for 1 minute. Okay, I think we can get started. I would like to introduce Johannes from Ascend, who will be our webinar host today. On my side, I will assist Johannes with Q&A session after the webinar. So, Johannes, now it's all yours.
Hi everyone, one moment, give you a picture of me. It's me, Johannes. It's my privilege to welcome you to today's Peplink broadcasting basic training. My name is Johannes and I work for Ascend in Germany. For the rest of the presentation, I will turn off my video. We are Peplink partners since 2018. We started partnering with Peplink due to the necessity of events. Transmitting and live streams and broadcasts was a requirement right from the beginning, so we are familiar with the tough requirements of live streams. We make it always work. This Peplink maxim brought Peplink and Ascend together, and this is why we at Ascend also use Peplink. Our today's agenda will cover an overview of selected Peplink products and a very basic overview on Peplink InControl 2. We will go through the device settings and the basic SpeedFusion configuration. We will start with a short explanation about the difference between load balancing and SpeedFusion bandwidth bonding, since it is essential to understand this difference. Peplink's USP is its patented SpeedFusion technology. But what's the difference between load balancing and bonding? Let's look at load balancing. Take a router with 2 internet connections. You want to send one single stream. Based on various criteria, the router has to decide which internet connection to use for this stream, as you see in the first animation. It cannot use both lines as the receiver would get confused about the different IP addresses. So it has to make a decision for one line. With bandwidth bonding, the router bonds 2 internet connections together to one virtual line and uses both of them for the same single stream. It does not have to decide for one single line. And here's an important note. For SpeedFusion bonding, you need a remote station, preferably in a data center, to reassemble the data packages. There is no bonding solution without a remote station. But there are service providers, of course, like Ascend, who offer these stations, so you can concentrate on your services. What happens when the line of a load-balanced router fails? As you see on the first animation, cold failover, the traffic on the line fails, meaning your stream will break. Then, after some seconds, the router will transfer the traffic to another internet connection. The important aspect is here your stream got interrupted, what all of us want to avoid. And in case of a moving vehicle connected to mobile networks, this would happen all the time as the router is changing from one cell tower to another, but not with bandwidth bonding. And this is the great advantage. Let's have a look at the big picture. Let's assume you have a 2 days full concert from which you want to send a live stream to your studio. Additionally, you want to have 2 VoIP calls transmitted. You want to have VoIP calls transmitted from outside into the concert. As you see on the picture, there are masses of people putting a heavy load on the mobile network. Failure is really not an option for you. So what to do in this case? We decided to use a Peplink MBX with 4 cellular connections and an HD2 as backup on site. In the studio, we used the Balance 380X with 2 DSL and an LTE uplink as bonding hub, and a virtual machine called Fusion Hub for the phone calls. This setup provided the connectivity we needed. As we learned earlier, SpeedFusion technology requires a remote station to reassemble the data stream. In this overview, we see a wireless router which is installed in the remote side, number 1. It builds 2 channels, seen number 2, via mobile network to a wired router in the headquarter or data center, number 3. This wired router could also be a Fusion hub on a hypervisor. So the data travels from the remote branch office through the SpeedFusion tunnel to the data center and exits here to the internet. Which devices can be used for live streaming? It depends a lot on your setup, but there are some devices which provide you with a lot of possibilities due to their flexibility. The most important feature is, in my opinion, the SpeedFusion bandwidth bonding capability. So all devices shown here have this capability. Also, most of the devices have one or more USB slots. In these slots, you can either plug a USB cellular modem or a USB RJ45 adapter, or even some mobile phones. Then these will serve as an additional WAN uplink. When talking about cellular modules, please note that most of them are downward compatible to 3G, so I will not extra mention it. Let's go through the devices one by one. The Transit Duo has two embedded cellular modems, meaning it can connect to two cellular towers at the same time, or to two providers. It has one Ethernet WAN port, Wi-Fi WAN, you can include a Wi-Fi as a WAN connection, one Ethernet LAN port, and provides up to 100 megabit SpeedFusion throughput. The great feature about this one is that you can power it easily with two power banks. I recommend this one, for example, if you want to send data from a bicycle or a backpack. The next routers are more for usage in vehicles. The HD2 has two embedded 4G connections, has two Ethernet WAN ports, also Wi-Fi as a WAN, one USB WAN, four Ethernet power over Ethernet LAN ports. It has 120 megabit SpeedFusion throughput. The bigger brother of the HD2 is the HD4. It has four embedded 4G connections, two Ethernet WAN ports, also Wi-Fi WAN, USB WAN, and 8 PoE LAN ports, and 150 megabits of SpeedFusion throughput. It keeps getting stronger while the outward size stays the same. The HD2 MBX has two embedded 4G or even 5G modules, cellular modules inside. It has up to 3 Ethernet WAN ports, depending on the license. It has Wi-Fi as a WAN. It has 8 gigabit Ethernet PoE LAN ports, 2 USB WAN, and up to 600 megabits of SpeedFusion throughput. So guess what's next? Yes, the HD4 MBX, the quad cellular gigabit LTE mobile powerhouse. It is also available with 4 times 5G. So it has 4 times embedded 4G or 5G modems. It has up to 3 Ethernet WAN ports, 1 Wi-Fi WAN, 8 gigabit PoE LAN ports, 8 times 1 gigabit PoE LAN ports, 2 times USB WAN, and up to 600 megabits of SpeedFusion throughput. And next comes a device which I recommend as hub unit or as field unit. The Balance 310 5G. Its outside measurements are similar to the HD2, HD4 family. SpeedFusion throughput is with up to 600 megabits per second comparably high, and it offers good mobile connectivity by having one 4G and one 5G module embedded, so 2 cellulars. And it offers a good connectivity as a hub unit by having a WAN port and a USB WAN, which can be RJ45 or a 4G 5G stick, which is also offered by Peplink. As I mentioned earlier, your selection for a device depends on your requirements, and what distinguishes Peplink is the flexibility of the devices. Flexibility is the keyword for my next device. The SDX Pro, a modular powerhouse, up to 1 gigabit SpeedFusion throughput, and I've seen it already at higher rates. All ports are configurable as WAN or LAN, 2 times copper ports, 2 times SFP Plus in the base model, 2 module slots. Available modules are 8 times RJ45 gigabit Ethernet, another module with 4 times SFP Plus, or 2 times 5G modules. You can use it as a field device, even if it's not that handy with its 19-inch, or you can use it as a hub device. The ability of hosting virtual machines makes it even more flexible. Let's step down a few steps again now regarding power, but only to step up again and have a look at the other hub units. The Balance 310X, it has up to 600 megabit speed fusion throughput, 2 gigabit Ethernet WAN ports, 2 USB WAN ports, and 1 LTE module. Is my definitive recommendation as a small hardware hub unit. The next two slides show the Balance 380X and the Balance 580X. These I suggest as hub units too. The Balance 380X has 3 Ethernet WAN ports. So if you want to combine more Ethernet WAN ports, and 3 Ethernet LAN ports, 1 USB WAN, and 500 megabits of speed fusion throughput. It can also be enhanced with 1 Flex Module Mini with 4G or 5G modules. The Balance 580X has 5 Ethernet WAN ports and 3 Ethernet LAN ports, 1 USB WAN, and again 500 megabits of speed fusion throughput, and can also be enhanced with 1 Flex Module Mini. Now we are heading to my favorites again, the SDX Pro we discussed already. Now we will discuss the smaller brother, the SDX, which is similar to the SDX Pro, but has only 1 Flex Module extension slot. It has also up to 1 gigabit speed fusion throughput and can also host virtual machines. Here comes the fully modular powerhouse with high-end performance. With 7 modules, you can have up to 56 WAN connections, up to 4 gigabit of speed fusion bonding capacity. Use it as field or as hub unit, as you wish. Adopt it as per your needs with modules. Just don't try to carry it in a backpack. With its 15 kilograms and around 300 watts of power consumption, it's not that handy. Last but not least, the Fusion Hub, the virtual hub, a possibility to use as remote station, as counterpart to the router in bonding. The virtual speed fusion appliance, you can host it on your own hypervisor, or we offer it as a service as per your needs. We offer you the Fusion Hub as a service, InControl on our instance, and our expertise. Just contact us for further details. For your convenience, you can also use Peplink Speed Fusion Cloud. Most of Peplink's care plans also have Speed Fusion Cloud included. You can activate bonding through the web interface of your router. Currently, you can bond up to 200 megabits per second to hubs all over the world, meaning you don't need to have a machine running in your data center or headquarters. Peplink will just take care of this for you. Let's have a very brief look at InControl. With InControl, Peplink is constantly pushing the boundaries in terms of remote management. InControl 2 is your complete suite to monitor, configure, manage, and back up your Peplink device, or a complete fleet of devices, or even get detailed reports, all zero touch. So what do we need to start? Well, first of all, we need a Peplink device which supports InControl 2. I personally never came across a device which did not support InControl. All devices we discussed with firmware 6.1 and above support InControl 2, and a lot of other devices do too. But your device needs to be under warranty or subscription. The alternative is to use a Send Peplink InControl. Contact us here again for details. Which requirements do we have on the networking side? From the Peplink router, all .peplink.com hosts need to be reachable. UDP ports 5246 and TCP port 443. If you host a private Peplink InControl instance, then please make sure that its IP is reachable from at least one network which is connected to the WAN port of the router. Sometimes you get a guest network which blocks a lot of traffic. Then the communication between the router and InControl might be disturbed. The router then builds a tunnel to the InControl server. The InControl server builds a reverse tunnel back to the router. For our usage, this understanding is sufficient. To use the Fusion Hub for bonding and other SpeedFusion techniques, you need ports 32015, which is the handshake port, TCP, and 4500 to 4505 in UDP. These are the default ports and can vary, but you can read them also out of the configuration from your device. As you can see, there are a lot of functions on the dashboard, but let's start at the beginning. How do I connect the device to InControl? Well, there's a little bit of touching. First, you need to unpack the device, connect it to power, connect your internet router with WAN 1 of your Peplink device. Then visit https incontrol2.peplink.com. Register if you have not done so. Hover over Organization Settings, click Add Devices, select the group, enter serial number, done. After a few moments, your device should turn green in the overview. How is the structure in InControl? There's a hierarchy. Organization is the highest. Below are the groups, and then devices in the groups. You can handle the user permissions very granular, and please do so and be restrictive. That's all I will say about it. You can see these descriptions behind the question mark when you set them up. Let's see what device settings we can do. Actually, you can build the SpeedFusion tunnels with InControl. You can steer and optimize your applications. You can set your Wi-Fi and captive portal if required through InControl. Centralize your network settings, firewall rules, VLANs, schedule firmware updates. And if you add new devices, just connect it to power, bring it online, add it to the group, and it will pull all information itself. Yes, it is possible to manage all centrally. But I personally prefer to set up each device individually, because in broadcasting business, we might want to set up each device individually for each event without risking to change configuration for another device. But still, InControl is indispensable. Let's see in a short some useful things. I will go through these slides quick now because we will repeat it in our hands-on demo soon. Peplink can make the password management for us real easy. Some people tend to leave the default passwords, which can be a security issue. Others set secure passwords and then forget them. With Peplink, you can have both. It sets a random password generated, secure passwords, and stores it securely for you. Let's see how we can use this feature. First of all, click on the group of devices. Then at the top, Devices, Settings, Device System Management. Here we can activate Device Web Admin and CLI Management, then assign a random password for each device. We can also have some other security feature sets here. We can deactivate read-only user, activate HTTPS, and redirect for our convenience. Also, we can allow web interface access only on the LAN port. When done, click Save Changes. Where do we find the password now? We find the password under the device details. To get there, please click on the group and the router which password you want to retrieve and show all besides the device name. Then you can see below admin user and password. When you click on the stars, your password will be revealed. What other useful feature is there? When you are on the router's InControl page, you can find under Settings, Remote Web Admin. Here you get through the internet on the router as if you were sitting beside it. Another useful feature is configuration backups. Every time you change a setting on the router and hit Apply Changes, a configuration backup is being taken. Where can you find these? At the same place where you find the password for the router, just a little bit below. Organization, Group, Device, Show All, Configuration Backups, and Download there. We will see more about it in the hands-on session. Let's go more into detail of the SpeedFusion technologies now. There is PepVPN too, but in broadcasting business, you should really rely on Peplink SpeedFusion technology. SpeedFusion is an enhanced VPN technology. The remote side builds a VPN tunnel between every WAN connection and every WAN connection of the headquarters. By this, both sides have full control over all the links and can detect, for example, latency and package loss. To fully utilize it, of course, you need at least two SpeedFusion devices, one field and one hub device, and at least on the field router, multiple WAN links. Then you can have bandwidth aggregation and multi-WAN reliability. A great feature of SpeedFusion are the different technologies you can use. In broadcasting, mostly you will want to use bandwidth bonding. It will combine the bandwidth of all WAN uplinks. Bandwidth overflow is possible too. It would use one line first, and when it reaches a limit, then it would utilize the next WAN connection. WAN smoothing in combination with bandwidth bonding is your preferred choice. By this, the attached WAN links are combined. Plus, your audio-video stream is sent redundant through two or more WAN links. Meaning, if there is package loss on one link, then the packages are still received through the other link. Example, you have a DSL uplink and 3 SIM cards from different providers. Then you can send your stream redundant through all 4 lines. There is hot failover too, meaning if one WAN uplink would completely go down, then the other would take over. First of all, I forgot to switch the slides now. So bandwidth overflow, I just explained. Then there is WAN smoothing, which sends redundant through all the uplinks. And then there is hot failover, which I explain now. Meaning if one WAN uplink would completely go down, then the other would take over. First of all, you really need a blackout of a line. Just a bad line would not toggle a failover. Second, even though the switch happens fast, some very little amount of data packages would get lost. And this you would see in your or hear in your stream. So this is something we really want to avoid. And that's why I don't recommend hot failover. Let's go through them one by one again. Hot failover is, for example, for an office or a hospital. You have a DSL or fiber line, and if it goes down, then you want to have 3 or more 4G, 5G lines to take over real fast. The hot failover would be your choice. It keeps the cost for the mobile cards low, and the switch happens real fast. Even if the switch happens really fast and the session stays intact, you would see the switch in the video stream. As I mentioned, I don't suggest it for streaming. If you can, go for a bonding solution. This one combines multiple WAN connections, bandwidth bonding. Please be aware that a 50 megabit DSL line and the 50 megabit LTE line don't end up in being one 100 megabit line. I will not try to predict the result as it depends on latency, package loss, and other factors. But through bandwidth bonding, you get a much cleaner line regarding package loss and latency. And this is really worth the loss of plain speed. In broadcasting, we are very unhappy if the line gives us speed like 100 megabits, but our stream, but we have, for example, 30% package loss. We'd rather be happy if the router recognizes the problem of package loss and throttles down the speed to the allowed speed to minimize package loss and give us a stable line. WAN smoothing, your choice if really all data packages have to arrive. With active WAN smoothing, you don't gain much speed by combining multiple WAN links due to the multiplication of data packages, but you gain a lot of safety that your data packages arrive at their destination. And usually in video streaming, you don't need that high bandwidth, but what you need is reliable bandwidth, especially when you are streaming from a moving vehicle, connecting from cell tower to cell tower. Additionally, it reduces latency and jitter because by design, it uses always the line with the lowest latency. It takes the first data package which is next in the sequence and forwards it. All other duplicate packages are discarded, so certainly try out WAN smoothing. IPsec versus SpeedFusion. I have never seen IPsec bonding multiple WAN links with a technology like WAN smoothing and the same ease of use, so I will not say much about IPsec. Let's get to the practical part and see some videos of how the configuration is done in detail. This demo will take around 21 minutes. After this, I will give you a quick information on our advanced workshop, and we will have our Q&A part. Please give me a moment. Let's begin with our hands-on session. We start by accessing the web interface via InControl 2. After logging in, we start out in our organization. To access the router's web interface, we click first on the group where the device is located. Then we click on the device itself. In the top center, we have Settings and Remote Web Admin. Once we click on this button, it takes a short moment, and we are connected to the router as if we would have accessed it through a LAN cable, which is directly connected to the router. So this is how we connect to the router's web interface via InControl 2. Let's do some configuration backups and restores. Every time we change a setting on the router and hit Apply Changes, our InControl instance takes a configuration backup. You can download these very easy by going to the organization, then the group where the device is, click on the device, click on Show All, click on Configuration Backups, Download, select the date and the time. Save as, and will be located in your Downloads folder. Now we want to restore this file. We click on Settings, Remote Web Admin. We do it on the device. Then we go on System, Configuration, Upload Configurations, Search. Then we select the file we just downloaded, Open, Upload, Apply Changes, and it's active immediately. Now let's do a firmware upgrade. There are at least two possibilities to keep the firmware up to date. One is via InControl 2, especially when you have many devices or you want to do updates automatically at night. InControl is your choice. You can manage firmware on organization level, group level, or device level. I will show the firmware management on the organization level. Let's check out first which firmware the hub is currently. We click on the organization, then on hubs, and here already we see firmware 8.1.0 build 4940. Now let's do the upgrade. Click on the organization, click on hover over organization, settings, then firmware policy, Peplink Fusion Hub. Select the firmware version you want to have, in our case 8.1.3. We hit upgrade only. We want to do it immediately. We could do it scheduled or when entering a geofence. And now we will hit Save Changes. And we see already the hub here under pending firmware update schedules. Let's see what the hub is doing. We click on Overview. We click on Hubs. We see status turned orange already, so the hub is working, and firmware says updating to 8.1.3. If we click on the hub, we see it's currently busy. Takes a few minutes for the hub to download the firmware, install it, reboot, and then connect back to InControl. As we see, the hub connected back and shows 8.1.3. Now we will downgrade the hub and do an upgrade via web admin on the device. So we will click on the organization, click on organization settings, firmware policy, select the firmware for the device, 8.1.0, remove upgrade only since we want to do a downgrade, immediately save changes. We will watch the hub again by using the overview, hubs, click on the hub, turned orange again because it's busy downgrading. We see updating to 8.1.0, which is actually a downgrade. Let's wait for a few seconds. Here it is. Now we will disable InControl firmware management for the hub. This we do again. Click on the organization, organization settings, firmware policy, Peplink Fusion Hub, select firmware management disabled. Save changes. Time is missing immediately. Now save changes. Overview, hubs. Now we want to do the upgrade on the device. We click on the device, settings, remote web admin. We had to disable firmware management on InControl first because we would do the upgrade and it could happen that it would do a downgrade again. So for safety reasons, we disabled it. Then we go on System, Firmware, check for firmware, download and upgrade. We should make a configuration backup before. This is done through InControl. Do you really want to upgrade the firmware? Yes, I want to. Now we wait again. We can watch the hub by clicking on the InControl tab. We see there's 12 megabits of data going through the hub. There are no clients connected yet, so we know that this is our firmware downloading. Hub turned orange, meaning it's busy. It did not connect to the InControl for the last 20 seconds, meaning it's doing a reboot currently. So let's wait till it comes back. So here it is again. Firmware 8.1.3. This is how we can manage firmware in InControl. For one device, for 100 or 1000 devices. Very easy. Let's set the LAN IP address. Some setups require that we change the LAN IP. To accomplish this, we go on the device where we want to change the LAN IP. We go on the router, our MBX again, settings, remote web admin. Then we go to, now we are connected to the device. We go to network. We click on network settings is already the first point. Then we click on untagged LAN. And then we can change the LAN IP. Make sure it does not collide with other networks which are attached to the router. Please consider the WAN ports as well as the networks connected and routed through the SpeedFusion tunnel and other connections. If they would collide, it would result in routing problems. I'll change it now from 50.1 to 60.1/24. In the DHCP range, I will also change from 50.10 to 60.10 and from starting address and the ending address to 60.250. We can enter here whatever is required for our setup. Save, apply. So this is the way how we change the. Some devices come with built-in Wi-Fi. We can configure that Wi-Fi device. This we will also do by remote web admin on the device. Since we are already connected, I will just use this session. At the top, let's click on AP, access point. We start out at wireless SSID. There is an AP controller also on many devices. Herewith, we can manage external access points if attached to the network. Now we will manage the integrated access point. There is a default SSID which comes with every device. Let's click on it to manage it. Here we can change the SSID, the Wi-Fi name. We can add a schedule on and off. We can change the VLAN. We can hide the SSID if we remove the checkbox broadcast SSID, then it would be hidden. We can change the security policy in type of encryption. We can change the shared key, which is the password. We can also look at it if we remove hide characters. This is very important to change the key. We can do some access control settings like restricted mode, deny all, accept listed, or some radius MAC authentication. We can do some guest protection. There are a lot of firewall settings also you can do here below. So since we did not change anything, now I will leave the settings as they are and click cancel. Next, look into settings. Here we can change the frequency, 2.5 GHz and 5 GHz. This SSID is active on both Wi-Fi bands. I suggest to turn off 2.5 GHz if all your devices support 5 GHz because 5 GHz frequency band is less polluted by other devices in the surrounding. Please make sure to set your operating country correctly to avoid legal issues. Default is USA. Since we are located in Germany, I changed the operating country to Germany. Also, the preferred frequency we set to 5 GHz if we use both. I also set it now to 5 GHz because it's definitely the preferred frequency. So for now, these are all settings. There are many more you can have a look at. Then we click Save. And at the bottom, don't forget to hit Apply Changes to make the settings active now. Now you can use the Wi-Fi with the SSID and the password you have set up. Let's configure our SpeedFusion tunnel on the hub and on the device. As we remember, for a SpeedFusion tunnel we need two devices, a hub and a router. Let's do a very basic SpeedFusion configuration by using InControl 2. We have a hub and a router in our organization. Let's connect them and see the ease of InControl. We click on the organization, then we hover over PepVPN SpeedFusion. We click on Configuration. We click on Add Profile. In our case, we like to select a star topology, meaning that all devices will mesh to or will connect to a central hub. Click Next. Since the device is already selected as hub DC03, we only need to enter the IP address or host name of the hub device. In this case, it is also pre-filled already. We click Next. We select the other endpoint, the device, which is our MBX router. Selected. Click Next. We give it a profile name, default, without getting creative. Then we click on Send all traffic to remote hub, meaning the router will send all its traffic going to the internet through the remote hub. Then we need to enter DNS servers. Let's use Quad 8 and Quad 9. Let's use WAN smoothing, normal. Click Next. Check the profile summary and click Finish. Save changes. That's it. The configuration will be pushed to the devices and they will build their SpeedFusion tunnel. Let's test the SpeedFusion connection. We click on the organization, then on the group, then on the router. Here, below PepVPN, we can see already connection to hub connected. Details, primary tunnel, remote device, it's online, it's active. So everything is fine here. Let's go on Settings, Remote Web Admin again. Click on Status, SpeedFusion. Let's look at the graph. We resize the windows, put one besides the other. So then we click on this little arrow here besides the SpeedFusion profile. And we start an upload test. We can test the PepVPN configuration. We use TCP. We send 4 streams. In upload, let's do it 60 seconds and start. Then we see already how the traffic is distributed. We have a cable connection which provides up to 50 Mbits per second bandwidth. We have a 5G connection. We have a Vodafone connection 4G and an O2 connection 4G. And now we see all in all, we have a bandwidth of about 140, 150 megabits in upload. Here we see only 70 megabits per upload. Remember, WAN smoothing duplicates the data packages. That's why actually we have 120, 150 Mbits all in all upload, but our net throughput is only around 70 megabits. And here in our graphic, we see how the traffic distributes. Dark blue is our WAN cable upload. Yellow, our LTE. Purple, our Vodafone. and the lighter blue, the O2 connection. So let's do the same download again, 60 seconds, start. So we have around 600 Mbits, 700 megabits download gross, and we have around 350 net. So it's quite some throughput. We have around 300 megabits in our 5G connection and 300 megabits in our cable connection. Also here we see the traffic distributed, now mostly through the cable and the 5G connection in the download. And this is already the positive effect of bonding. You don't need to distribute the data by hand or by fixed settings or whatever. The router does it automatically. There are many more parameters where you can influence the way of distributing, but this we will teach, or we will do in our advanced course together. So if you are interested, more information later. So this is how we test the SpeedFusion connection and verify it. So as I mentioned, there is an advanced workshop. There you will learn about antenna basics, using and configuring USB adapters, integrating Wi-Fi WAN into SpeedFusion, creating outbound policies, VLANs, SpeedFusion deep dive. Preferred settings for different streaming protocols, port forwarding, layer 2 tunnels, setting up high availability, notifications in InControl, OpenVPN, captive portal, firewall rules, and content blocking. And if you have some special requirements for your application, you can let me know and we will address them too. Feel free to write to marketing@peplink.com or get in touch with me at info@ascent.de. So next, our questions and answers session.
Okay, thank you, Johannes. I suppose he was really good because we have almost no questions. I forwarded one question. Maybe you can, share with others also, or your experience about this one.
Well, WAN smoothing duplicates the data package. Okay, does forward error correction needs to be used in combination with WAN smoothing, and which one do you recommend and why? I went away from forward error correction again since we had some problems with some streaming encoders, especially with SRT protocol. They first sent the data, the images, but after a few seconds, the stream dropped. The connection got disappeared. But this did not happen with WAN smoothing, only with forward error correction. Forward error correction sure has less overhead than WAN smoothing, but you really need to try if it works with your streaming encoder. So you can try it actually quite easily. Just send a stream and then see which works best for you. We always adopt it per encoder. So, but my better compatibility, the higher compatibility is with pure WAN smoothing and no forward error correction. I hope it's answered.
Let's see. Okay, thank you for sharing your experience. Okay, we see one question, a few more questions coming in. Let's check those.
I think the frequency bands manually, I need to check. I think it's in the latest firmware included already.
It should be by the end of this year, I suppose, but yes, okay. I need to check this.
Okay, maybe you can send that by email and we will check that. Latency diff on WANs. You can do that by clicking on the question mark. There are a lot of settings. Latency cap. Yeah, latency difference, cutoff, latency cap. What's the other one which I always like to use? My English. This setting for package loss. If you experience package loss, then remove the line for a certain amount of time. There's also a setting behind the question mark in the SpeedFusion settings. So always click on the question marks. There are a lot of settings behind.
Okay, I see no more questions coming in. Well, anyway, guys, if you have any questions, you can always contact our partner, Ascend, which have a huge experience in broadcasting, or you can also use Peplink forum or community page. We have a lot of engineers who are willing share their experience, and you can ask, and I'm sure you will find who will help you. So thank you again for attending our webinar, and see you next time. Thank you, Johannes.
See you. Stay safe. Bye. Take care.
Yes. Goodbye.